Greetings, fellow explorers. This is Tony with Fount Systems Network, and we're here in pursuit of low-carbon innovations for seawater desalination. Today, I'm going to be looking at the Department of Energy's Clean Water Processing Technologies Summary Report from 2018. It's a compiled and edited summary of 3 DOE workshops that were held between 2015 and 2017. Those workshops focused on innovations to desalination. You're going to get a high-level summary of the report here of the major themes in it, and I'm also going to offer some personal insights toward the end. If you're new to Fount Systems Network, I'm going to post a link here, and you can see our work plan. You'll get a sense of where we are in the process. And if you like what you see here, please like and subscribe to our channel. Let's get started. So first, a little background. The U.S. Department of Energy has an office within it called the Office of Energy Efficiency and Renewable Energy. And within that office is an Office of Advanced Manufacturing. So that office collaborated with the Office of Fossil Energy to hold a series of clean energy or clean water processing workshops between 2015 and 2017. The workshops substantially focused on desalination, and the DOE invited people working in the water purification industry, scientists and researchers, DOE staff, as well as NGOs to hear keynote addresses, panel discussions by industry leaders, as well as to participate and contribute to more open format workshops. In the back of the report, there's a list of the participants in the workshops, and there were hundreds of names listed in there. If you're wondering why the Department of Energy would host a Clean Water Processing Technologies workshop, I'll refer you to a prior episode on the energy-water nexus. The Department of Energy's interest is in maintaining the resilience of the U.S. electrical power system. The electrical utilities rely entirely on having a steady supply of clean water for its operation. This steady supply that the utilities have relied on for the last 100 years is at risk of disruption by climate change. 80% of the report summarizes the workshops, and the workshops focused a lot on technology that would improve the performance of seawater and brackish water desalination systems. There's a real focus on reverse osmosis in it. Importantly, there's a research or background summary on global water stress, and this identifies a major motivation to developing alternative water resources, which these technologies can help access. You might remember that we covered global water stress in a prior episode. I would say the most critical theme in the report was around increasing the use of water purification technologies that would improve the availability of alternative water resources, and not just seawater and brackish water, but also notably highly polluted industrial effluents as well, also called process water. So I broke the near-term opportunities down into 3 categories. We've got the industry or general needs for the industry, reverse osmosis technology, and thermal technology. Under general industry needs, there was a theme of a need for computer modeling for water stress, and this seemed to come from local utilities that have to model or predict future water supplies as part of their services. There was a need for a research and development consortium, and there's a need for pilot tests and test sites. So I'm perceiving there in the industry a fairly fragmented private or local approach to water purification solutions. And so the R&D consortium and the pilot test sites look like ways to increase collaboration. Under reverse osmosis technology, membranes and sensors. So there was a need for research to develop more durable membranes, more selective membranes. That really gets into maintenance that degrades the longevity of membranes under that durability component. And I think on selectivity, I need to learn more about this, but I think membranes are primarily designed to remove sodium chloride. Biofouling is a big deal, and we'll talk a little bit more about that. Scaling prevention, I think that's on the brine discharge components as they're piping. Highly saline solutions back out of the systems, I suspect that they're subject to scaling. On the process sensor side and the integrated monitoring control side, It just sounds like there's a need to better understand the water quality as it is introduced and cycled through the system. On the thermal technology side, notably, there are no thermal desalination plants in the United States. So you here at Fount Systems Network know that we've been looking at thermal desalination technology in the Gulf States region, for example, and it's pretty highly developed in the Gulf States region. Under innovations there, nonetheless, it came up there were needs to improve materials for scaling, fouling, and corrosion resistance, and also better, cheaper, and more durable heat exchangers. So for some of the longer term opportunities, this is really on the innovation and research and development side. I'll be honest, I don't know what any of this stuff is, and I need to look more into it, so I apologize. I'm going to be just reading a lot of this to you, but I broke it down into 3 categories again. We have novel purification technology, novel brine treatment, which is on the effluent side, and then the systems design. Under novel purification tech, they're identifying membrane distillation, humidification, dehumidification cycles, forward osmosis, selective and reusable sorbents, reusable materials capable of selective ion removal. Under novel brine treatment, capacitive deionization, electrosorption, and markets for concentrates. And this was kind of an interesting theme on markets for concentrates. Remember, on the effluents, a lot of that is treated as waste that is most conveniently disposed of. And here they're looking at harvesting valuable or useful chemicals from the effluent to, in turn, market. Finally, on systems design, I'm going to get a little bit more into this in the next section, but they're identifying modular systems, process intensification, and fit-for-purpose systems. There's a recurring theme of water quality, or variable water quality, that runs through the workshops. It seems to me that seawater and brackish water desalination facilities are designed for a certain water quality, or more likely a range of water qualities, and that would be based upon a known or predictable set of criteria. For example, salinity or total dissolved solids, or water temperature, for example. So it sounds like reverse osmosis is especially sensitive to varying water quality, and that it can cause increased system maintenance. It also sounds like algae creates real headaches for reverse osmosis utilities. Like if there's an algae bloom near the water intake, for example, it can really foul up the membranes further along in the process. Or maybe it's just algae in excess of design parameters. I don't know. So this discussion about sensors and process controls points to a need for more responsive systems so that operators can keep a close watch on water quality at the water intake for idiosyncratic events like that. The need for more robust membranes points to this as well. Along this theme of variable water quality, there's this very broad category of produce water, which I think is problematic. Municipal water treatment, effluent, agricultural runoff, industrial effluents, and especially fossil fuel effluents look like they all get lumped together into this single category of produce water. It looks to me like all of this produce water gets treated as externalities by the utilities and businesses that generate it, and I suspect it's because they can dispose of the effluents most conveniently in injection wells, where there's less incentive for them to understand it. Agricultural effluent is very different from municipal water treatment effluent, and just within the category of industrial effluents, there must be tremendous diversity. So lumping all these together is problematic because the term doesn't even close to describing the water quality that can be expected from a given source. I need to learn about everything in the report, really. For one thing, there are some very juicy references in the report, like the slide decks from the various presenters at the conferences, and the DOE makes those slide decks available. One thing that really catches my eye is this idea of process intensification, which I've never heard of before. It sounds like it's a way of combining steps in a given purification process into a single off-the-shelf module that, when you combine those steps together, it becomes much more efficient. It also sounds like process intensification fits really well with this theme of modular systems. So I'll be looking more closely at that in the future. So that's it, everyone. I hope you found the summary of the report as educational as I did. If you like what you see here on the Fount Systems Network, please like and subscribe to our channel. And remember, everyone, keep exploring, keep growing. I'll see you next time.